Hey everyone, it's that Math Magician. On this video, we're going to take a look at systems of equations, and we're going to see if we can use the substitution method to help us solve for a point of intersection for two lines. So let's jump right into this problem where I have two different equations here. I have negative 3x minus 3y equals 3, lots of 3's there. The second equation is y equals negative 5x minus 17. Notice that this is a great example for us to use the substitution method because I have one variable already isolated. Look at that second equation there, y equals. I know that y is equal to negative 5x minus 17. Now that's going to be very helpful for us in a second because we're going to substitute that into the first equation for y. Let me show you exactly what I mean by that. I'm going to write out my second equation. Negative 3x minus 3y equals positive 3. Notice that I rewrote that first equation, but I did not write the y variable. And there's a reason why I didn't do that, because I know what y equals. Look at that second equation. It tells us that y is equal to negative 5x minus 17. So instead of writing this y variable, I'm going to substitute in what y equals. So I'm going to write negative 5x minus 17. That is the substitution method. Now we're not done. There's still some more algebra for us to get through. But that is the basis of the substitution method. Take what y equals, substitute it into the other equation. Now we can solve for x. And let's go ahead and do that. First things first, we need to distribute that negative 3 out in front. So I have negative 3x, negative 3 times negative 5x. That'll become positive 15x's. Negative 3 times negative 17 will be positive 51, equaling 3. Let's go ahead and combine our like terms. I see two x terms there. Negative 3x plus 15 more x's will give us positive 12x. Still plus 51 equaling 3. Now our next step here is to isolate that x term. To do that, I'm going to take away this 51 on the left side to move it over to the right side, right? I want to take that 51, move it over. I'll do that by subtracting 51 because look what happens. These 51s cancel out. They zero out. I'm just left with 12x and it equals 3. Take away 51. Well, that will end up equaling negative 48. We are almost there. I almost have x by itself, but I have 12 x's. I don't want 12. I want 1. So to do that, we will divide both sides by the coefficient of 12. The 12's on the left cancel out to 1. We're left with x equaling negative 48 divided by 12. That is negative 4. So we now know the x term for that point of intersection. Okay, I'm going to go ahead and write my final answer up here. I know that the x term is negative 4. I still need to find, though, that y term. It's still missing. And we can find that because look at that second equation. It tells us what y equals. We know that y is equal to negative 5 times x minus 17. Well, look at this. We happen to already know what x equals. We just solved for it. So since x equaled negative 4, we'll put it in right there, substitute it back in, negative 4, and we will solve for y. Alrighty, let's finish this problem out. Negative 5 times negative 4 will give us positive 20. 20 take away 17, that equals 3. So I'll go ahead and put that up there. That right here is our point of intersection. Negative 4, 3. That is how we use the substitution method to find the point of intersection with two different equations. It's that Math Magician, and I'll see you on the next video.